Okay.
Hey, I did add.
So let's start. There's been a bunch of talk about question number 6. Okay. So here's kind of the setup. I'm kind of modeling this. So I've got my laser, and I've got a small mirror over here. So I'm going to shine the light like this. It's going to hit the mirror, and then I'm going to try and hit Wyatt's arm over here. Okay? So imagine, so this is what we've got. So I'm shining it off there. Wyatt. Okay. So it's right there on Wyatt's shoulder.
Good job,
Okay.
Mr. President.
All right. Done. All right. So just kind of get the visual. So I'm shining it here. It's hitting that mirror, and then it's bouncing off that way.
Gotcha.
Now, if this was symmetrical, if Wyatt was at the same point that I was, the problem would be simple. Okay? But he's farther back, and that's what you're getting on this problem. So there's a couple of different ways you can do this problem. Okay? I'll show you what I do. So if you look on this diagram,
You went there.
I'll do you one better.
Why are you using your book? Are you using your book?
Yeah.
Come here. We're going together.
Okay.
Right.
Yes.
Ready?
Focus. Okay. So here's the main assumption that you have to make. Is that as long as it's a flat mirror, that it's symmetrical, that the angle of incidence equals the angle of reflection. Okay? Two values, these two are going to be the same. So if you look at this, what I did, I said, all right, well, I'm going to look at this as like a triangle. Okay?
Triangle.
So based upon this, since these two angles are symmetrical, I'm going to work off tangent. The tangent is opposite over adjacent. So again, there's any number of ways you can do this. Is just what I did. I said, okay, I'm going to let this be X, and I'm going to let that be Y. Okay? You could call it red and blue, A and B, squirrel and dog, cat. I don't care. It doesn't make any difference. But here's what I do know, is that the tangent of the angle of incidence is going to equal that side opposite, which is Y, over the adjacent side, which is 10 centimeters. Right? Everybody cool with this?
No modest ways.
So yes, sir. Okay?
Yes.
Cool with how I'm starting.
Yes.
Now, that has to equal the tangent of the theta of that angle of reflection, which is going to be X over 15 centimeters. Okay?
Yes.
Right? Go with it. Now, because these angles are symmetrical, they're going to equal. So I could set these equal to each other. So y over 10 is going to equal x over 15. But here's the problem.
We have two variables.
I have two variables, but only one equation. But I also know that the distance between A and B is how much?
15.
15.
Why 15?
Right? The distance between that entire distance, right, is 15.
Oh.
So the distance between A and B is going to be what? 10.
Yeah, that's what I meant.
So I also know that x plus y has to add up to 10.
Oh my gosh, you're a genius.
Oh! Now, how many equations do you have?
Two.
How many variables do you have?
Two.
Right, I did not have 15.
Substitute.
So now you can do the substitution. Again, it doesn't make any difference. I just solved for x and I said, hey, x equals 10 minus y. Right?
That's so smart.
Then I took that and put that in here. So I have y over 10 equals 10 minus y over 15. Now how many variables do I have? One in one equation. Then it's just cross multiplying. Taking 15 times y equals 10 times that. Now, when you get y, how can you find x?
Plug it back into x plus y.
Because x plus y equals
10.
10. So your answer to number 6, which is in the back of the book, but anyway, yeah. So, oh, no, it's not. That answer to number 6 should be around 10 centimeters.
Wait, I have x and y. No.
Bad boy.
I have x and y.
How's it on the board? See, I used X and Y.
Yeah, you have x and y. Now what do you do?
I like Nathan's method, but this works too.
Well, it's Alyssa and mine.
Well, what,
Oh,
from here? Cross
No,
multiply.
I solved for x, y. I have x and y.
What am I doing?
I can't take.
So the question asks for how far above the mirror do you aim down? So with mine, once you find y,
Yeah.
then you'd add 5 centimeters to it.
Oh, okay. So 9 centimeters.
Got it. Okay, got it.
So you don't really need to solve for x.
Yeah.
What?
Yeah, you do. Because if
Oh!
yeah, you don't, but you do in the sense that
Yeah.
yeah,
Well, you don't need to get the numerical value.
you don't need the numeric value.
Oh, that's incredible. I like that.
Absolute cinema.
I promise you, I'm going to tell you this right now. I promise you, on the test, you were going to have a question like this.
Okay, but it's like just like this one.
That concept.
No.
I promise
Will
you.
you give us a diagram of like it?
I'm going to give you a diagram like this. I'm going to change the numbers.
Now for word films.
Huh?
Are there going to be word films?
Oh yeah.
You
There's going to be so many
Diagram,
problems.
diagram.
What do you mean
I
diagram?
need to see what's going on.
Nathan's way doesn't make any sense.
Oh yeah, this is, if you like diagrams, this is
Just
gonna
one
be
big
your wheelhouse. We're gonna have so many
Yeah,
diagrams.
that makes sense. That would have
But on the test, like, you won't give me like four
makes
pages
sense.
to read, and I have to come out with some random rays and angles.
He's actually gonna give you his autobiography, and you're gonna figure out how many fifty.
Good one, Adam. That's hilarious.
What?
That's the point. It doesn't make any sense.
I gathered that
No,
part.
Really?
I love it when people go, do you have any kids? I go, not that I'm aware of.
You have like 100. You have like legitimate. Your legitimate kids are us.
That's valid.
Wait.
My bad, Jack. I got you.
Don't unroll it.
Okay,
Don't
put
roll it
that
back.
away. Put that away.
We don't want to see it naked. though.
First track.
Yo,
Yo, can I see it?
Okay. Now, let's talk about number 9. Okay? And how that's going to look. So on number 9, this is all about where the problem number 9. Okay? So let me kind of give you a visual of what's happening on number 9. So on number 9, here's the water, here's the boat, okay, right? And the person under the water is down here, okay?
Yes.
So on number 9, what you're told is that an underwater diver sees the sun 50 degrees above the horizon.
Right.
Okay? Now, you have to understand with optics where the light is traveling. So to see the sun, is that emanating from the diver going out towards the sun, or is the light coming from the sun and into the diver.
From the sun to the diver.
From the sun to the diver.
Yes.
Okay? So the light's coming in like this, right? Now, when it hits the water, what's it going to do?
Go down.
Go down.
It's going to bend down like this. Okay? Cool with this. Now, you're told that you're told that he sees the sun 50 degrees above the horizon. So from his perspective, this is a 50-degree angle. Okay?
Wait, how do we?
my
So
What?
how do we just draw like the normal one or something?
Just chill out.
Hey, I think he's gonna explain.
So this is a 50-degree angle. Cool with this. Now, if you were to make this into an angle, right? And this would be 90,
Okay. Okay.
if that's what you want to think.
And they add up to
So
Okay.
what would this angle in here then be?
180 minus 90 minus 50. 40.
No.
Yeah.
How about 40?
Yeah, 180
180.
Good. Good.
Okay.
Dude, I need to call Mr. Crawford.
Cool with this being
Oh
40.
my, bro, so that means it's 40, like, I don't even know.
Just stop talking. Stop talking.
Dude, Gavin, you're right.
I'm gonna tear your boat.
What is happening?
What is
Is that
that?
maybe-
Why is he
maybe all this
blocking
shit-
us?
Okay?
There you go. I'm gonna,
Gavin, you're getting in trouble again.
you're right.
You're gonna get yelled at.
Oh, very much so.
Right, the person should just know that.
So, on number 9, here's what you're asking. How high is the sun actually above the horizon to a fisherman in a boat above the diver? So, what you're asking eventually is going to be this angle out here.
Yeah.
Okay? That's what you're trying to find.
Right.
But this index of refraction law only works with angles that are relative to a 90-degree normal line. Right?
Oh my, that's why we need the 40.
Oh, that's why you need the
I
40.
used 50.
So the light is coming in like this. So you have N1 sine theta 1. So the index of refraction of the water is 1.33. So you got 1.33 times the sine of 40 degrees.
Right?
The new index of refraction going into the air is going to be what?
1.
1 times the sine of theta 2. But now, here's the tricky part. When you find theta 2, where is that measured at?
From the normal.
When you find theta, that's that angle.
I got 31.
Thanks for giving me the answer.
You should write down.
What does normal mean?
That's a relative term.
He wasn't being normal. I was paying attention.
How about
Not if you ask that question.
He has a lot of questions.
Got a lot of issues.
Wait, first, back to the 50. How do I know it goes right there?
Because
so.
it says an underwater diver sees the sun 50 degrees above horizontal.
If Simon says jump off the
Horizontal is this.
It's above the x-axis.
I know, so it's 50
Well, you're
degrees
under it.
above horizontal.
Oh, I thought it was 50 degrees like above the wall.
No,
No, it's the.
diver under the water. So imagine this. You're the diver, okay? We're here. You're floating under the water. You happen to have a large protractor with you, okay?
Only for camp.
You see the sun at a 50-degree angle
Oh.
above here.
Or Cam, throw something at him.
Oh, so the interesting
Yes.
Huh?
where our brains are expanded.
What's the question?
Yeah.
Okay. On number 10,
I don't even care if it gets over that. Worth it.
Relative to the income.
On number 10, that index of refraction should obviously be bigger than what? 1.
It's like a bad GPA. Really bad GPA, right?
Horrible.
So your index of refraction on number 10 should be between 1 and 5.
Rick.
Wait,
Between 1 and 5.
Okay?
that's the whole spectrum.
1.37.
On
Yeah.
number 8,
like 1 and 2.
on problem number 8, it's a little wonky how they kind of asked this problem.
Definitely is.
So here's the main thing that I want you to see, because on 8.8 it says, after striking both mirrors, at what angle relative to the incoming ray does the outgoing ray emerge? So here's what I really want you to get out of this, is that here's this mirror, and then you have a second one, and you're told that this one comes in at a 35-degree angle. Okay? So if this comes in at a 35-degree angle, what does it have to be that? So it's going to bounce off here at a 35-degree angle, right? Now, it's going to hit this mirror, but what's this angle going to be?
55.
That's going to be 55,
Where's the
which
mirror?
means it's going to bounce off like
55.
at a 55-degree angle. Okay? So that's why I said there's a couple of different ways you could answer number 8. So now here's the bigger question, and I screwed this up on how I drew it. But do you think these two lines here would be parallel?
Yes.
So that's the other way that you could say it, that they would just bounce off and they would be parallel.
So answer parallel.
You could do it that way.
Can I just say
Or
it's
you could
parallel?
give the angle down here. I don't got you
right now.
Now, let's talk about
I guess I owe you a dollar.
let's talk about question 4. Okay? And this is important in terms of like what you are able, what allows you to see something. Okay? What allows you to see something. So you're walking along, unpaved road in the woods, sounds a little creepy, with a flashlight pointing at the ground, and any water-filled potholes are noticeable because they appear much darker than the surrounding dry road. So you're walking along, and you're shining the light for all the world to see. Right? So, and this boils down to what allows you to see. What allows you to see the road?
Light bouncing back.
Light bouncing back at your eyes. Right?
Indeed.
Okay? Light bouncing back towards your eyes.
Sí, señor.
Because if it doesn't bounce back towards your eyes, what does it do?
Bounce away.
It acts like a mirror, and it just goes that way.
Gone.
So the only way you can see anything with your flashlight is if it hits something in the road and bounces back. Okay? Because that has to be the path. It has to bounce back from this surface to your eyes. So if something appears as a dark spot, what is not happening? The light is not bouncing back towards your eyes. It's like a stone hitting the water and it's skipping off. Okay? So remember this. The only way you can see something is if the light bounces off of it and hits your eyes. Or it just emits the light like the light does. Okay? So keep that in mind. When you get to question 7, okay? So keep in mind what I did yesterday with popcorn, okay? So popcorn can only see me if
She can see you.
she can see,
Yes.
right? Right? So right now, I can't see popcorn in that window.
She
Why?
can't see you.
She can't see you.
Because if you look at this, here's the window, right? So imagine that I shine this laser, okay, at the mirror, Okay? So imagine that was actually like a mirror. Okay? Alright?
Yo, where the light go?
So there it is there. Okay? So imagine that was actually a mirror. It would hit and it would go out like this. Okay? Right? So, again, keeping in mind how light works and what you have to see. So the reason that, if I'm doing this, the reason that I can't see popcorn is because she's here. So if her light hits and bounces off, that goes like this. Okay? My light bounces off and goes like that. So her light is bouncing off, but I can't see it because I'm not in that path. But if I stand up, okay, and I move a little bit, okay, like I can see Alyssa right now. Alyssa, can you see me? Okay, I can see Alyssa. I couldn't see Alyssa when I was over there. So I can draw a line from me to that glass, bounce off, boom, I can see Alyssa. Now, Alyssa, can you see me now? Okay, so if I move too far over, so now that line of intersection doesn't hit on the mirror. So I can't see her. So if you can draw a line that intersects like on the mirror and you can see the other person, you can see it. So with that said, on problem number 5, okay, you should be able to see 2 points on problem number 5. Okay? And 2 points only. Okay? So on that question then, with the mirror, on number 7, it says, is this reflection you would expect to see on the mirror surface parallel to bar? Where is the man facing her in the mirror actually standing? Okay? So, again, if you look at this, and it's kind of a weird painting. So, with that one, if you look at in terms of where that image would have to be, so if you look at this, she's here, the mirror is here. So that light is bouncing off like this, okay? So this is why this won't work, because of the fact that the geometry is just all wrong, okay? Got it?
Got it.
Okay. Any other questions on that assignment?
You just need the hypotenuse.
None? Once, twice, sold? Okay, stop you on the camera.